So just a quick video trying to explain correlation and causation. So to do this, we're going to try and do this via an example to hopefully get an understanding of what we're talking about. So we're looking at the daily temperature in degrees Celsius, and we'll go for McDonald's ice cream sales. So you'd expect if the temperature's hotter, you're probably going to sell more ice cream. But what we're going to do, this data is just completely made up just to try and show what I'm talking about. So it's not real data, but hopefully it lets you understand what we're doing. So on our first day, that hot, that many sales. Second day might have been a little bit cooler. We might have had a few less sales. Right, so we're starting to see that the temperature is influencing the sales that we've had. Third day's a bit warmer, we've had more sales. Right, nothing there, bit warmer, few more sales. This day here was warmer, but there wasn't as many sales. So it doesn't, what this means is that the temperature doesn't directly change the amount of sales. Now, it's a hypothetical situation. This day, the machine could have broken down. The shop might have closed early. Something might have happened. We don't know what it is, but it shows that just because the day was hotter, it doesn't mean that there was more sales. But a hotter day will probably give you more sales. And if we finish that off, you end up with these. So it's a correlation because one thing does affect the other. You can see a relationship between them. But you can't say that the temperature causes more ice cream sales because there are other factors at play as well. Another thing that you can look at with this, before we get into that last bit, there's two sentences here, and one is an increased temperature caused an increased number of ice cream sales at McDonald's, and an increased temperature was associated with an increase in ice cream sales. Pretty much for general maths and further maths, if you see the word caused, you've got to go back to think about this. It's not one thing causes the other because there are other factors. So it is that one thing will influence the other or one thing will be associated with the other. So if it's a multi-choice question, the caused can pretty much disappear straight away. For it to be a causal relationship, it's a thing like if you drop a pen, it causes it to fall. It has to be that exact thing. But anytime we're looking at data, we're looking for the relationship or the association between them. Just a quick thing to point out again how correlation and causation can be slightly different. This data is taken from a web page there that you can see, and if you look down the bottom, it's where it got its data from. But they've compared the data of the divorce rate in Maine and America with the per capita consumption of margarine, and you can see that the two things sit very, very similar. There's definitely a correlation between them. But can you possibly say that the divorce rate in Maine is causing a change in the consumption of margarine? And it just doesn't make sense. So you're looking for a correlation, you're looking for the relationship between two things, not necessarily that one thing causes a change in the other.